There are numerous ways to represent a function, including set notation, a map, a graph, a table, and an equation that relates the input to the output. Function notation. For a function named f, the notation f of x is the value assigned to the input x. The letter f names a process, an input-output device, that assigns to each allowable input x an output or y value. Lowercase f is the device that maps input onto output. So here we have f of x, so we input x and we get f of x as our output. The device is set notation, a map, a graph, a table, or a formula. For a function named f, the notation f of x is the value assigned to the input x. The letter f names a process, an input-output device that assigns to each allowable input x an output or y value. Alright, so here's an example with set notation. Given f equals 1, 3, 2, 5, and 3, 7, evaluate f of 1. That means that when x is 1, what is y? So here we go through and we see, this is where x equals 1. When you put 1 into the function, you get 3 as an output. So this answer is 3. What about when x equals 2, f of 2? Here we find the ordered pair that has x equal 2, and the output is 5. Solve for x. F of x equals 7. When it's written this way, that means that the y value, wherever you see f of x, you can think that's the y value, equals 7. So we go through and we see that the y value equals 7 when x equals 3. Therefore, x equals 3. Here are the answers written nicely. The graph of a function. Suppose f is a function that maps a real number a, the input, onto real number b, the output. Then the point a, b is on the graph of f if and only if f of a equals b. There are finite functions where the elements of the domain can be counted, and infinite functions where the elements of the domain cannot be counted. Because of this, a set of ordered pairs, a map, or a table is a convenient way to display a finite function, while the graph of a function is a compelling way to display infinite functions. Here is a graph example. Given the graph of f, evaluate f of 2. Alright, so our input is going to be 2, our x value. So we go to x equals 2, and I'm going to draw a little vertical line. So this is where x equals 2, and we see that the point is right there at y equals -2. So the answer is -2. So when x equals 2, you just see where the red dot is, or where it intercepts the graph, and it intercepts right there at y equals -2. Solve for x. F of x equals 0. So that means that the y value is 0. Now that happens at 2 different points, which is okay. You're allowed to have 2 different points that end up at the same y value. You just can't have 2 separate points that have the same x value. So the answer to this would be when x equals 0 and when x equals 3. Both of those are going to give you a y value of 0. And we are correct. Evaluate. All right, a is f of 0. So when x equals 0, what is y? When x equals 0, so we look at this line here, we see the graph intersects right up here where y equals 5. B, f of 5 plus 3. So when x is 5, that's here, we see that y equals 0. So this becomes 0 plus 3 equals 3. F of x equals 0. So where does y equal 0? So y equals 0 here and here. This is where x is 1 and where x is 5. So x equals 1 and 5. Both of those give us a y value of 0. And finally, f of x plus 4 equals 0. Therefore, f of x equals -4. We'll subtract 4 from both sides. So where is the y value -4? 1, 2, 3, 4. So we look here and we see, y is -4 right where x equals 1, 2, 3. So x equals 3. And here are all of the answers. Here's a formula example. Given the function that maps an input x onto the output 3x plus 2, evaluate f of -2. All right, so all we have to do is plug -2 into the function. 3 times -2 plus 2. So wherever you see an x here, you replace that with -2. So 3 times -2 plus 2, that's -6 plus 2, which is -4. That's our answer to A. For B, solve f of x equals 3. All right, written like this means that this function equals 3. So 3x plus 2 equals 3. What is x? All right, so 3x equals 1. X equals 1/3. You can see that we have gotten both of these correct.